If you're a schoolchild and you were to draw a scene to put the sun in the sky, what crayon do you reach for? It's always a yellow. This notion has been with us since childhood that the sun is yellow. And that is not even close to being true. The sun in broad daylight is too bright to look at. Hence, the time most people find themselves looking at the sun is when it's low on the horizon. When the sun is rising or setting, it has a deep yellow color. Sometimes it's so deep it can be amber to red. It's a common misconception that the sun is yellow, or orange, or even red. The real color of the sun is actually white. The sun is essentially all colors mixed together, which appear to our eyes as white. This is easy to see in pictures and videos taken from space. If the sun were yellow, then snow would be yellow. The fact that snow looks white is evidence that it's being illuminated by white light. The sun's radiation graph peaks around 500 nanometers. So, in reality, it lies within the blue-green cyan light zone. To our naked or unaided eye, it tends towards white. Let's look at the explanation for this. The Earth has an atmosphere wrapped around it. An atmosphere mainly containing nitrogen, oxygen, and carbon dioxide. If the sun is directly overhead, it goes through one thickness of atmosphere, top to bottom. When the sun is overhead, in comes in white light. The atmosphere scatters light a little bit and the rest of the light makes it all the way to Earth's surface. The individual components of visible light are not affected and we receive pure white light with an overhead sun. As the sun gets lower and lower in the sky, the path of light through the atmosphere is longer because now you got an angle through it. The lower the sun gets on the sky, the more atmosphere it has to pass through. In fact, if calculated, the equivalent atmospheres light goes through amounts to about 5 to 6 times of atmospheres. So, what the atmosphere does to the sun rays while it's high up overhead, it's doing it 5 times that and more when it goes lower on the horizon. Particles in Earth's atmosphere happen to be the same size as the wavelength of light of the blue side of the spectrum, hence it scatters blue and violet out of sunlight. The remaining colors red, orange and yellow are less easily scattered and they reach the Earth's surface and our eyes. Photons in the lower end of the spectrum, red, orange and yellow, are less easily scattered. Photons in the higher end of the spectrum, blue, indigo and violet, are more easily scattered, thus making the sky appear blue. And that's why we have a blue sky. Hence, the setting sun is a simple yellow, or amber on the horizon. And sometimes, an even more mesmerizing mix of color. Another related concept is red shifting of light and the Doppler effect. Blue shift occurs when a light source moves towards an observer. Red shift occurs when the light source moves away from an observer. If a star was moving towards the observer, then the light waves produced by the star in front of the star would be compressed together, giving a high-frequency light wave. High-frequency visible light is of a blue color, so we call this blue shift. If a star is moving away from an observer, the light waves produced behind the star will be stretched out and this will give low-frequency light waves. Low-frequency visible light is of a red color and this is called red shift. This can be seen with stars when we look out in the universe, that the stars have a red tinge or red shift, showing that all the stars are moving away from us. This indicates that the space between stars is getting bigger and therefore the universe is expanding.